So today we're going to talk a little bit about speed. You will occasionally be asked a question involving speed on the AP exam. Um, it's not a hard topic, but it's not one that books always cover particularly well. So you'll have a worksheet. Actually, you have a worksheet for this. So you all know that speed is the absolute value of the velocity, right? Speed is how fast something is moving without thinking about which direction it's moving. Velocity has a sign, either positive or negative, okay, relative to something that's holding still usually. So, a couple of quick questions, and I know these are kind of baby easy. This is partly because, again, this is something that I got from Dixie Ross, and she has had a very open policy about who could be in calculus. No, I mean, seriously. And so she had people where I'm like, they're never going to pass. Yes, but it's good for them. And I'm like, okay. I think it's better to be challenged at a level where you can pass than challenged at a level where you have zero hope. That's just, it's a philosophical difference. So, what effect does absolute value have on numbers?
It makes it positive. If it's negative, it's positive.
And what's the other possibility?
I don't know.
You talked about positive numbers and negative numbers. There's one other possibility.
If it's zero,
Yes.
then it's zero.
Yeah. It makes negative numbers positive with the same magnitude. And it does not affect zero or positive numbers. Okay, so that's pretty straightforward. So, what effect does taking the absolute value of a function have on the graph of a function?
By any magnitude, that's like all the numbers that are below the x-axis, it's mirrored above the x-axis.
Okay,
But anything already above the x-axis, nothing happens to it.
and again, there's a third possibility.
And nothing happens to the zeros.
Yeah, so the zeros don't change. Anything above the x-axis doesn't change, but anything below the x-axis is reflected over the x-axis. So parts of the graph below the x-axis are reflected over the x-axis. Parts of the graph on the x-axis or above are unchanged. Right? And this is leading up to an understanding of something. I could just give you the rule for speed, but we're going to lead up to it, and I think you'll understand it a little bit better. Okay? So, let's move on. So, in each of the following examples, the graph of a differentiable function giving velocity as a function of time is shown from time 1 to 5, along with selected values of the velocity function. For each example, fill in the values for the speed in the table and sketch the graph of the speed. Then answer the questions based on that table and those graphs. All right, so this is the simplest one. All right, if the velocity is 1 at time 1, what is the speed? 1. And the velocity is 2 at time 2, the speed is 2, and so on and so forth.
I'm a real philosopher.
Pardon?
I'm a real philosopher now.
A philosopher?
Yeah.
How does philosophy have anything to do with this?
No, I was just. I don't know. No, it's because you said that this teacher had different philosophy when it came to.
So what students should be in AP Calculus?
Yeah. He influenced my thinking.
So basically, he added a word to your lexicon and then you continue to use it incorrectly.
I mean, they really use it incorrectly. You could say the context of using it was incorrect, but they used the word incorrectly.
So in this example, the velocity is it positive or negative?
It's a hard question.
It's positive.
I thought you were a philosopher.
I'm not a mathematician.
And is it increasing or decreasing?
Increasing.
And increasing. Because the velocity is increasing, what do we know about the acceleration? Be careful before you answer.
It's positive.
It's positive.
It's not increasing. We just know that it's positive.
Correct. We know that it's positive. By examining the values for and the graph of the speed, we conclude in this example that speed is speed increasing or decreasing?
Increasing.
Increasing.
I wish our AP physics test were this easy.
Yeah. All right, moving on to the next example.
It's mirrored or reflected.
So, what's going to happen to my speed values?
It's
They're going to be the same as the velocity values, really?
as the last speed values.
Oh, okay. So 1, 2, 4, 8, and 16.
Yeah.
So 1, 1, 2, 2, 3, 4, 4, 8, 5, 16. All right, in this example, is the velocity positive or negative?
It's negative.
It's negative. And is it increasing or decreasing? Think carefully about that before you answer. Again, we're looking at velocity.
It's decreasing.
It's decreasing. Because the velocity is decreasing, we know that the acceleration is negative. So, is speed increasing or decreasing?
It's increasing.
It's increasing. We're going to put all this together in just a couple of minutes. Notice in both of these cases, the speed was increasing. Okay, let's look at the next one. What?
An idea is forming. I'm not going to say that.
Okay,
I'm thinking.
so let's take a look at this one. What kind of speed values are we going to have here? Positive. It's the same as the velocity values. So we'll plot that 116, 2, 8, 3, 4, 4, 2, and 5, 1. So is the velocity positive or negative here?
It's positive.
It's positive. Is it increasing or decreasing?
Decreasing.
Wait a minute, I heard both. Which is it?
Decreasing.
Decreasing. And because velocity is decreasing, what do we know about acceleration? It's negative. So is the speed increasing or decreasing? Decreasing. Huh. Well, that's different than the first two. Let's look at the last one. So the speed will just be the absolute value for the velocities. So 16, 8, 4, 2, and 1.
She couldn't spice up the numbers each time?
No.
I don't think a truck is that small an engine.
I like that there's a guy who lives somewhere near me because I see his car from time to time. He's got one of the newer Corvettes. And I'm like, you're going like 20 miles an hour and accelerating slowly, but it sounds like,
I mean, all cars can sound like that.
you're being shot out of a rocket or something. I'm like, it's fine if you want your car to sound like that when you really are, but you should be able to switch that stuff off.
It's hard because you gotta.
Might as well just get a PA system in a golf cart and play that noise.
Yeah. All right. So here, the velocity is
Negative.
And is it increasing or decreasing? Increasing. Because the velocity is increasing, what do we know about the acceleration? It's positive. So the speed is decreasing. Okay, so has your germ of an idea come to fruition?
Do you still
It
remember
needs
it
more
right?
nutrients.
Pardon?
It needs more nutrients before it's ready to be shared.
All right, well, look back at the first two. In both of those, our speed was increasing, correct?
Yeah.
What is the same about both of those?
That if the velocity is positive, it has to be increasing. If the velocity is negative, it has to be decreasing.
Wait a minute, the velocity.
The velocity.
Okay. So look at velocity and acceleration. You've almost put it together.
If velocity is
the
negative,
signs match up.
the acceleration is negative.
And
Vice versa. If it's velocity is positive, then the acceleration is positive.
so when an object was speeding up, the velocity and acceleration had the same sign. And honestly, the way I think about that is they're working together. They're not working against one another. So the object is speeding up. On the other hand, what happened when the speed was decreasing?
Acceleration was decreasing.
Acceleration was decreasing on both of them? I don't think so. And we never even looked at whether acceleration was decreasing.
Velocity was decreasing.
Velocity is increasing right here.
This one, we're talking about this graph. Yeah.
I'm talking about 3 and 4.
Okay. The signs are.
The signs of what?
The signs of velocity and acceleration are opposite from one another.
Yes, the signs of the acceleration and the velocity are opposite one another. So what?
They're working against each other.
They're working against each other. Exactly right. Okay? It's sort of like, if you can think about it, you may have seen this. Some athletes work out this way where they have basically what amounts to an enormous rubber band that's around them. No, if you'll let me finish. that is attached to an immovable object and they start running. So what happens is the further they get away, the greater the resistance. So although their velocity is positive, they're slowing down because their acceleration is negative. Okay? So, in which examples was the speed increasing? Which ones?
1 and 2.
1 and 2. When speed is increasing, what do you notice about the signs of velocity and acceleration?
They're the same.
They are the same. In which examples was the speed decreasing? 3 and 4. When speed is decreasing, what do you notice about the signs of velocity and acceleration? They are opposites. Okay, so if you're asked, is something speeding up or slowing down at a particular point, you simply find the velocity and the acceleration at that point and compare the signs. Are they the same sign or are they opposite signs? And don't forget that even if you have a really ugly expression for the velocity, for example, the acceleration is the derivative of the velocity, and you can do that on a calculator without finding the formula for the acceleration.
Math 8.
Indeed. Students tend to forget Math 8
What? How can they? So
because we don't use it nearly as often as we use Math 9.
I used to use Math 8.
Yeah, we
Previous
used
unit.
it in the previous units a lot.
Because if I wanted to like just graph the derivative and like chuck it in.
I almost used it on my test.
Okay. All right. So that is it for the lesson. Again, many thanks to Dixie Ross of Pflugerville High School.
Where did you meet Dixie Ross?
Probably I met her for the first time at